right, today we're basically becoming detectives. We're on the hunt for a very sneaky culprit, one that hides in plain sight and twists the truth right under our noses. And its favorite crime scene? It's something you've seen a million times, a simple survey.
Come on, be honest with me for a second. Have you ever been filling out a questionnaire and, maybe fudged the details just a little bit? Maybe you said you hit the gym a little more often than you actually do, or that you're always a fantastic team player at work.
Look, we've all done it. It's a totally human thing to do. But here's the problem. For the scientists who really depend on that data to make new discoveries, this tiny, harmless little habit creates a massive issue. It's like a ghost in the machine, a phantom that haunts their results and makes it incredibly hard to tell what's real and what's just, well, an illusion.
So let's get our investigation started. It is time to put a name to this ghost, to finally meet the prime suspect behind all these skewed results. Okay, so this ghost has an official name, Common Method Bias, or CMB for short. And the idea is actually pretty simple. It's an error that sneaks in when all of your data, all your evidence, comes from the exact same source at the exact same time. So, for example, if a survey asks you about your mood, how much you like your job, and how well you slept all at once, well, how you're feeling in that one moment can kind of bleed into all of your answers. That's our ghost right there, hard at work.
Now, our prime suspect doesn't work alone. Oh no, it has a couple of key accomplices. The first one is a biggie, social desirability. That's just our natural human instinct to want to look good, to present the best version of ourselves. The second one is called acquiescence, which is just a fancy word for our tendency to just agree with things, to go with the flow because it's easier than really thinking it through. And this quote from the research just nails that first accomplice, social desirability. It's that little voice in our head that pushes us to give the right answer, the socially acceptable one. We're not exactly lying, but we're definitely curating our image.
So why is this such a huge deal? Because this bias isn't just some tiny little statistical problem. It can completely hide the true story in the data. It can make two things look like they're connected when they're not at all, or it can hide a real connection that's there. So the bottom line is it can lead researchers down a totally wrong path to completely wrong conclusions.
Okay, so if this ghost is so sneaky, how in the world do you even catch it? How do you prove it was at the scene of the crime? Well, this is where our detectives really start their investigation. And every great detective story needs its heroes, right? In this story, our heroes are the researchers Layla Karimi and Denny Meyer. They decided to tackle this problem head-on, and they came up with a plan to not only find the ghost of bias, but to measure exactly how much trouble it was causing. So here's the case file. Our detectives surveyed 341 university students. They asked them about their general well-being, their emotional intelligence, and, now here's the really important part, their alcohol habits. And all this info came from a single survey they filled out themselves. So the challenge was obvious. When you're asking about a sensitive topic like drinking, how much are people's answers being influenced by that urge to look good?
To find the truth, they couldn't just guess. They needed a kind of high-tech forensic tool, something that could find the statistical fingerprint left behind by our ghost, the common method bias. And this is how they did it, and it's brilliant. They built this complex statistical model. Think of it like this. You've got circles representing the real topics they were studying: well-being, alcohol, emotional intelligence. But then they added another factor, a new circle right in the middle. That's our ghost. They designed the model specifically to see if that ghost was secretly pulling the strings on all the other answers. So they ran a few different scenarios, kind of like testing theories. First, they ran a model that completely ignored the ghost. And as you can see, it was a poor fit for the evidence. Didn't work. Then they tried a model that included the ghost but assumed it affected all the questions equally. That was better, but the real breakthrough was the last one, the model that let the ghost's influence change from topic to topic. And bingo, that was by far the best fit. It proved not only that the ghost was real, but that it haunted some parts of the survey more than others.
And that brings us to the climax of our whole investigation. After all the tests, all the evidence, what did our detectives actually discover? It's time for the big reveal.
Now, at first glance, the data looked pretty solid. The researchers got a reliability score of 0.84. In the stats world, that's a good number. You look at that and think, great, this data is solid, we're good to go. But that was the score with the ghost still lurking in the numbers. Then
They used their special tool to statistically remove the ghost, to basically exercise the bias from the data. And wow, look what happened. The reliability score plummeted all the way down to 0.66. All of a sudden, the data looked a whole lot less reliable than it did a minute ago.
So let's put a single number on this. The ghost of social desirability was actively puffing up the results, making the data look about 18% more reliable than it truly was. That is not a small error. That is a massive distortion.
But remember that final test they ran? The one that was the best fit? It hinted that the ghost wasn't haunting every part of the survey with the same intensity. So that leads to a new question. Did this bias affect all the topics equally?
The answer was a definite no. And this part is fascinating. The researchers discovered the bias had a pretty low impact on questions about general well-being, but it had a much higher impact on questions about emotional intelligence. And the highest impact of all was on alcohol habits. And that makes perfect sense, doesn't it? The more sensitive or personal the topic, the stronger our urge to look good, and the more that ghost of bias completely warps the results.
Okay, so our detectives cracked the case, they found the ghost, they measured its influence, the case is officially closed. But the lesson from this whole investigation is just getting started. So let's talk about why all this really matters.
In the end, it really boils down to something simple. Better detective work, which means better scientific methods for finding and fixing these kinds of biases, just leads to more trustworthy science for every single one of us. It's about making sure the things we think we know are actually built on solid ground. And what's so exciting about this particular study is the tool they used. You see, older methods for doing this kind of ghost hunting were incredibly complicated, often requiring scientists to do calculations by hand. But the new procedure they used here is way simpler and can be done with modern software. That is a game changer. It means it's now way easier for all scientists to check for these ghosts in their own data. And that is the ultimate payoff. By using these more advanced methods, the entire scientific community can be way more confident that their big findings are reflecting reality, and not just some statistical illusion created by the ghosts in our data. It makes the whole foundation of science that much stronger.
So we'll leave you with this final thought. We've seen how a very normal human impulse can create a ghost that seriously haunts scientific research. It really makes you wonder, doesn't it? If a ghost like this can live inside a simple survey, what other invisible forces, what other hidden biases are out there shaping the data we see and trust every single day?